Good day, viewers. You are welcome back to Tindanious Maths and Science Tutorials. Today we are going to consider exponential functions. Okay, how to integrate exponential functions. All right. So, viewers, if you are new here, kindly visit my previous lecture videos on differentiation of exponential functions using the shortcut approach or method, as well as using the long way approach using the chain rule formula. Today, let's tackle integration of exponential function using the shortcut method. I'll also work or treat the same topic, okay, using the method of substitution, that is integration by substitution. In order to receive all my updates, make sure to click on the bell button to subscribe. Let's go straight to the point. Now, when you integrate exponential x this way with respect to x, okay, whenever you integrate e to the power x or exponential x with respect to x, so the dx here simply means differential of x, okay. Now the result is you still get your exponential x plus an arbitrary constant, and that arbitrary constant is what is known as what? The constant of integration. As simple as that. So, viewers, I've also proved why exponential x dx is equal to this. Alright. Okay. So, having done this, let's consider examples. So, when I have exponential, any number at all, let's say you have 10 x with respect to x. Now, using the shortcut approach, what you do is you repeat this whole expression or this term over here. So I'm going to repeat this term, which is what? Which is my exponential 10 what? 10x. That's the first step. Then the second step is you have 10x, right? When you differentiate 10x, what do you have? You have 10. Okay, in other words, 10x, the coefficient of x is 10. So you divide it by what? By the coefficient of this, which is what? Which is your 10. Then plus your what? Plus your constant of what? Of integration. So this is just the same as 1 over 10 times exponential 10x plus what? Plus c. Have you seen how simple it is? Let's consider another example. We have exponential 4x dx. You repeat this, okay? You just repeat the same thing, copy and paste. So you have e, that's exponential 4x, then all over 4x. When you differentiate 4x, we have 4. So that one will become your what? Your denominator. Remember, we are still dealing with indefinite integrals or indefinite integration. So you add constant of integration, and this is simply the same as what? The same as 1 over 4, then e to the power 4x plus what? Plus your c. Let's consider this exponential e 5x dx. Applying the same convention or the same norm, you have what? You copy, then you paste it, right? So you have e, that's exponential 5x, then all over what? When you differentiate 5x, what do you have? You have 5. So 5, then plus c, which is the same as 1 over 5, then exponential 5x plus what? Plus your constant of integration. Furthermore, we have the integral of, let's say, 4 exponential 2x dx. When you integrate this, what are we getting? So what you do is this. You just repeat, you just do copy and paste, okay? E to the power 2x, this way 2x, right? And what is happening? This function is multiplying the constant 4 this way. Is that not so? So in other words, you just repeat the whole term over here, then all over. Now when you differentiate 2x, what are we getting? We are getting 2 this way. So what happens? 2 divides 4 2 times. So I have what? I have 2, then exponential 2x plus what? Plus your constant of integration. Now the last example to end this tutorial, we have let's say you have 10 exponential 5x dx. You copy and paste, right? So you just repeat the same thing. You have 10 multiplying exponential 5x, then all over. When you differentiate 5x, you have 5. So that one will be your denominator plus your constant of integration. Again, this divides this 2 times. So we have 2 exponential 5x plus the constant of integration. Viewers, this is the end of the tutorials under integration of exponential functions using the shortcut approach. So I'll also bring you a video session using the long way approach, which is popularly known as integration by substitution. Bye.